All right, so we're working on the word problems for the setup for optimization just to get the formula down. So continuation on. So number 3 is a bowl in the shape of a hemisphere with a radius 6 inches is filled with water to a depth of d inches. Express the radius of the surface of the water as a function of d. All right, so we have to have everything in terms of d. So we're going to do radius in terms of d. And we have this bowl here, and I've got the radius marked in there, or the center. And then the radius would go out to the edge of the bowl. And then I could drop down to the bottom of the bowl at a 90-degree angle there. And what I could do is to figure out my values here. I know certain things that I'm given. I know that I have 6 inches for my radius. So this is not quite to scale, but I've marked in here, I've got the radius going across the top of the bowl is 6 inches, and then down to the bottom of the bowl would be 6 inches. But what I'm trying to figure out is the how it what the radius is for the water line there. Okay, so if I think about the water that's going to be in there, I'm going to just shade that in, and that would kind of be maybe right about here. I don't exactly know. I'm just saying some depth D. Okay, so this little piece here, darken that up, that I'm going to call D inches. Okay, that's the depth of the water. So this little diagram helps me hash things out and figure out what's going on in the problem. And what I'm trying to find is the radius for the depth, and that's what I don't know. So I'm gonna just mark that across here. So this is the radius that I don't know for the depth. Okay, but I do know a lot of different things, and I can piece it all together. So see if you can do that. I'm going to give you a hint that you're going to use the Pythagorean theorem. So you have to figure out what triangle you want to look at in here. And if you can label this in terms of what I'm given for the bowl, then that will help you. Like what are these like missing pieces? Okay. So the way I'm looking at this is if I could make a triangle here, then I could use the Pythagorean theorem to figure out what this radius is of the water line there. So in order to do that, I would actually need to know what this edge is. So I'm going to just draw in this triangle that I want to identify here and see if I can get all the pieces going. So this strip here, this height, would be 6 inches is the whole piece minus D wherever the water starts, right? So this one is going to, I could label it as 6 minus D. And this other piece that I've already labeled as R, I've got that as, included. So I'm going to just draw a little triangle out and set it out aside. Taking this whole triangle here and just putting it over there for you. And so I have R, I have 6 minus D, And I need one more piece. Well, I know that the radius from the center out to the edge of the bowl is 6. So this would be 6 inches. That's like a standard thing that was given. So now if I want to find out what R is in terms of D, I can use the Pythagorean theorem, right? So I can have the hypotenuse is going to be my 6 inches. So we'll just label that there. And I have a formula, c squared equals a squared plus b squared. It doesn't really matter which one of these we call a or b, but we'll just do it in this fashion here. So we'd have 6 squared equals r squared plus 6 minus d all squared. And now we just need to solve out for r using algebra, and we're going to take the principal root when we do the plus or minus. So I'm going to subtract my 6 minus d from both sides there. So then I would end up having 36 minus 6 minus d squared equals r squared. And then I would want to take the square root of both sides, plus or minus, but I really only want the positive because it's a length, so we're only going to have a positive. I'm going to just switch this around so the variable's on the left. And then for this one, to clean it up a bit and make it look nicer, I think I will actually just expand that out and then simplify it. You can try that on your own over there if you want, but I'll just do it aside and show you the steps. So if you want to work it and then come back, so do that as a classwork. Okay, so here's my little aside over here that you can see the math where I expanded this 6 minus d squared to be 36 minus 12d plus d squared. I just did the square both ends and double the product of the two terms. And then when you do that, though, be careful that you keep your parentheses around there because you need to distribute this negative. And so sometimes that's where people will make an error. They'll get the wrong answer here. So those will cancel out, and I'm left with 12d minus d squared. So that goes under my square root here. R equals square root of 12 minus d squared. And again, you can just leave it like that. And even if you left it here as the 36 minus quantity 6 minus d all squared, if you put that into Desmos, you would be good. But make sure you have this square root to get the radius. So that should be, I'm going to actually write that as r of d because it's r as a function of the depth of the water. And then the domain, again, what would be reasonable would be anything between 0 and 6 in relation to the bowl. Because if you didn't have any depth, then you wouldn't have the water in the bowl at all, kind of thing. And you wouldn't want to overflow the bowl, right? Maybe it could go right up to the tippy top. So we could put less than or equal to 6 would work there too. Okay, I'm going to do a separate video for the next one, for number 4, for Sue's walking in the desert.